Hi, my name is Doug. Welcome to another Emerald Hill Skies Skylet. In these Skylets, we present something related to the craft of astronomy. Sometimes a review, sometimes something that we're learning about a particular piece of equipment or the craft. Tonight, we're sharing an update about the James Webb Space Telescope. You might remember that the JWST was launched on Christmas Day. Well, what's been happening since then, and where does it stand right now? That's what we're going to be working on today, partly because outside things are still kind of cloudy. We've got the scope set up, as you can see out there in the observatory, got the roof rolled off and we're ready for business. But here's a little camera we keep aimed toward the sky, and you can see it still looks really mean out there, doesn't it? Sorry to say, but never fear. We're going to be able to see, I think, sky before it's over. Here's a little app that we use on the web. It's Clear Outside, and I bet some of you all use it as well. You can see, I'm going to refresh it here so we see the very latest. You can see that sometime around now, we're supposed to start seeing the sky, so we can always hope, can't we? In the meantime, let's go take a look at what's been happening with the James Webb Space Telescope. You might remember that, let's see, we'll get you looking here. This is the screen that we recommend you go to when you want to learn what's happening with Webb, and it's just called Where is Webb? In fact, you can go up to Google and just say, Where is Webb? And the first link that you typically get is the one you want to be able to go here. Right here, you'll see a PERT chart that explains what's going on. You can also look at another view of this. In this view, you're able to see how Webb began. On Christmas Day, you can see it inside of this Ariane 5 rocket ship. It launched successfully. That was Christmas Day. Deployed the upper stage and began its long trip. During the trip, its solar array was released and fully deployed. All the mid-course corrections went well. In fact, we didn't have to do as many corrections as we thought we would. So we actually were able to save fuel compared to what we thought might happen. And that enabled the James W. Webb Space Telescope to last even longer than we had thought. I'm just going to check the audio here to make sure. Yeah, the audio sounds good. Then we began deploying the forward sun shield pallet. This was all while the the JWST was en route, and deployed the deployable tower assembly, which was important. Keep in mind, all these steps had to happen perfectly because we couldn't send people out to repair the JWST if something had gone wrong. On the way out, we began unfurling the sun shield covers and released those. The sun shield port mid-boom was deployed perfectly. The starboard mid-boom went well, and the sun shield layer tensioning went well. All 5 layers of the sun shield deployed perfectly. The secondary mirror swung around into place, and then the instrument radiator was put into place. At that point, we saw the mirror wings start to swing around, both on the right side and the left side. After that, we began to see those mirrors kind of bond together and start trying to work as one. Once Webb was fully deployed, we kept making that journey, out to Lagrange 2. While that was happening, mirrors began moving, and we began tracking what each mirror was seeing. Fortunately, that went well, so we were able to figure out then with each segment what each segment would look like. We arrived at Lagrange 2, L2, which is that point about 1,000,000 miles farther from Earth than we are from the sun. Uh, Once we were out there, we began that orbit, kind of a figure eight, outside the Earth. So as the Earth trails around, the Webb is out there 1,000,000 miles farther, where it's kind of in the Earth's shadow, you could say. We began cooling instruments and we began imaging with each of the specific segments. Um, Once we saw all those images, we were able to sort them out so that we were able to identify them. We were able to arrange them in perfect alignment and then bring them together as one. So the James Webb Space Telescope would see in a unified vision. And we began the fine phasing so that we'd be able to see as one point. And then we began cooling each instrument down to its final operating temperature. That's completed. And now we're at the point that we can actually begin instrument commissioning. We've got a little video here that we'll try to show you about this. Let's take a listen and mute my mic.
Hey, John, how are you doing?
Fantastic. Hey, John. Welcome.
Good morning. We're going to give everybody an opportunity to concur, but...
Yep, I concur.
Okay.
All right. I hope you can get a sense then of.
Hi, everyone. I'm Fraser Kane. I'm the public.
Hope you can get a sense of what that's like, being able to see this final commissioning that would happen then. Keep in mind that since the days of Galileo, we've used telescopes, but not a telescope like this near-infrared camera, the near-infrared spectrometer, the near-infrared imager and slitless spectrometer, the mid-infrared instrument, and the fine guidance sensor all together make for the finest telescope that's ever been invented. And it's in the perfect place to be able to operate. 1,000,000 miles farther out into space than Earth is from the sun, kind of in the shadow of the Earth. And out there, it won't be picking up any kind of radiation from the Earth itself. There'll be no clouds. Take a look at the clouds tonight and the way our sky looks like. Out there where the JWST is located, there are never going to be any cloudy nights. And it will be able to see things that we've never seen before. So during the next 2 months, let's continue to be patient as each of these instruments is commissioned. And that just simply means warmed up and calibrated, much the same way that we might calibrate one of our telescopes. We might take this RASA 11, for instance, and we might put the camera on the front and then adjust the back spacing, adjust for any tilt. And this takes hours and hours and hours. And I still don't have mine perfect. I hope once we get totally warmed up this summer, I'm going to spend hours and hours out there getting this thing ready. Well, that's basically what we're doing with the JWST right now, calibrating all those instruments so we'll be able to see with the best possible detail ever. Now, keep in mind, people that have been working on the JWST since the late 1990s have now finished a half of a lifetime. You know, they've finished 25 years getting to this point, and they will now be retiring, so to speak, from some of this launching process. And the people that have been waiting for this moment to do science with the JWST are now going to be fully on deck. So thanks for watching. Thanks for kind of celebrating with us that we're ready now for full instrument commissioning. It'll probably be late June before we'll be able to actually start doing science with the JWST. We'll look forward to that date. If you like content like this, I hope you'll subscribe if you do like this. And also maybe if you want, click a thumbs up. Doesn't cost you anything. Gets it out there in the heads up radar of others. Hit the bell if you want to be notified when we're doing impromptu nights like this. And we'll look forward to talking to you again. Thanks for being with us tonight. And good night from Emerald Hill Skies.